And welcome to our video on finding the least squares regression line using the formula. The equation of the least squares regression line is given by this formula here. So I would make sure that this is in my summary book so I have it if I need to find it. So the time you would be using, this would be the by hand method. You would be using this if you have a question where you are given the summary statistics. And there's an example of a question down here where you're given x bar, standard deviation of x, y bar, standard deviation of y, and the Pearson's R. If you're given all of those, or you've previously worked them out for this data in a previous question part, then you would need to use the formula to calculate the least squares regression line equation. If you're not given these summary statistics and you're just given the raw data, then you can use your CAS, and you need to enter the information into your CAS and use that. That will be on a separate video. Using the formula. Now the equation looks like this, the final equation. Y equals a plus bx. Now this equation, it's an equation of a straight line. It's related to the one we use in our linear graphs unit, which is y equals mx plus c. And we say usually c is the y-intercept and m is the gradient or the slope. And we could rewrite this one as y equals c plus mx. Whoops, not equals, plus. So I've just moved these two around. It's like saying 3 plus 5 is the same as 5 plus 3. Doesn't matter which order you say it in for addition, you can move these things around. So I've got the y-intercept first and the slope and the x value second. The formula they've used here, the y and the x are still the same, but instead of c for the y-intercept, they're using a, and instead of m for the slope, they're using b. Now the reason they have it in this backwards looking way is that this is the way that statisticians, people who use statistics, this is how they write their linear equations, and we need to be consistent with the way they do when we write our statistics. So when you're finding an equation of a regression line, you need to write it in this way, and you can use a for the y-intercept and b for the slope or the gradient. When you are talking about linear graphs, you can use this general formula. Just got a plane flying past me. I'm not sure if you can see it on the video, but that's what the noise is if you can hear it. The slope of the equation, so this is the b, the number in front of x, is given by this formula. B equals r, which is Pearson's R, times the standard deviation of y, divided by the standard deviation of x. And the y-intercept, which is a, is y bar, the mean of y, take away b, which we found in here, times x bar. And it explains down here, r is the correlation coefficient, Pearson's R. Sx and Sy are the standard deviations of x and y, and x bar and y bar are the mean of x and y. Got a warning down here for you. Really important, the very first step whenever we're finding a regression line is to make sure you know which one is the explanatory and the response variable. If you incorrectly label them, then you will get an incorrect solutions. So you need to be really clear. Remember, on our scatter graph, the explanatory variable is on the x-axis and the response variable is on the y-axis. Okay, first example. First example here says the heights and the weights of 11 people have been recorded and the values of the following statistics determined. So they're giving you all of the summary statistics. So this is a perfect question to use the formula. Oh, and it even tells you, use the formula to determine the equation of the least squares regression line. So I'm just going to highlight, that's what it's actually asking me to do. That enables weight to be predicted from height. Calculate the slope and the intercept correct to two significant figures. So I'm going to highlight that as well so I remember at the end. Okay, first step is to make sure we're clear about the response and the explanatory variable. So they've given it to us here, the x and the y. So the response variable is the y, which is weights. And the explanatory variables is the x, which is heights in this example. If you weren't given this, you'd need to make sure you were clear about which one's x and which one's y. First step is to jot down our formula from up here. I'm going to start with the equation of a line, y equals a plus bx, and then we need to find a and we need to find b. A equals, nope, I'll start with b. This is the slope, RSY over SX, RSY over SX, which equals, normally you'd work down the page, I'm just working across to save some room. Pearson's R is 0.8502, S of Y is 7.594, S of X is 7.444, and when you put that into the calculator you will get 0.867. That's to three significant figures. So I'm not going to round off to two significant figures just yet. I'll do that at the very end. So we have B to fill in, we need to find A. A equals y bar minus B times x bar. Minus B times x bar, which equals y bar 65.45 minus b, which is this. This is why I didn't fully round it to two significant figures yet. 0.67 times x bar 173.3, which equals negative 84.8. Our equation for a regression line, back to this one, y equals a plus bx. We can sub in a and b now, so y equals a, and this needs to be to two significant figures. So 2 would be 8, 4, look at the third one, 8, so this changes to a 5, negative 85 plus b, two significant figures, 0.86, this will change to a 7, 0.87 x, and that's our final equation. Check. We're asked to find an equation and we're asked to find it to two significant figures, so we're done. Thanks for watching the video.